For the past 6 months, the entire scientific community has been watching the mysterious Three-Eye Atlas with unusual intensity. Astrophysicists have been puzzled by its trajectory, its color, its chemistry, and deep down, many hope that this strange object might finally prove that we're not alone in the galaxy. Because the idea of extraterrestrial life is our collective unfinished story. We see so much out there in the cosmos, and it's hard to accept that in all that darkness, among countless stars and planets, there could be no other life. The real question is whether we're even looking in the right way, or imagining alien civilizations correctly in the first place. I'm going to answer these questions and more right now. So pour yourself a cup of tea and get ready for a journey in search of life beyond Earth. Our first stop is Mars. Ever since humanity began studying the planet up close, theories about life there have multiplied. Some claimed life existed long ago. Others insisted it might still be there, hiding from us. But what if we created life on Mars ourselves? For many years, we believed that the spacecraft we send to other worlds were almost sterile. Clean rooms, engineers in white suits, filtered air, surfaces blasted with heat, chemicals, radiation. Temperatures reaching 100 to 120 degrees Celsius. The electronics barely survive, but the goal is simple: kill everything alive. Then biologists took samples from one of these clean rooms, the very place where NASA assembled the Phoenix lander. They grew the samples on petri dishes, and after many days, something new appeared. A species of bacteria no one had ever seen before. They named it Tersicoccus phoenicus, after the Phoenix lander that touched down on Mars in 2008, meaning we officially discovered an organism that survived all our sterilization procedures and lived comfortably inside a clean room designed specifically to prevent its existence. Now imagine this. The Phoenix lander touches down on Mars while carrying a hardy Earth microbe we failed to eliminate. Yes, Mars has no real atmosphere, the radiation is brutal, and in theory all of that should kill the bacterium. But Phoenix carried one clever instrument, a self-hammering probe meant to dig several meters down to measure heat flow from the Martian interior. It didn't reach the planned depth, but it still burrowed a few centimeters under the surface. That thin layer of soil above it, a shield. Less radiation, more stable temperatures, gentler conditions. If Tersicoccus phoenicus could survive the torture chamber of a terrestrial clean room, there's a real chance it could tuck itself into cracks, tiny cavities, under a piece of hardware, and then into the slightly protected Martian soil around that probe. Not guaranteed, but the chance isn't zero. And here's the unsettling thought. The first alien life that future missions discover on Mars might turn out to be our own microbe, the one we brought there. In other words, one possible answer to where will we first find extraterrestrial life is painfully unromantic, in traces of our own contamination on Mars. And this isn't comedy. It's an actual issue in planetary protection. The more we poke around the solar system, the harder it becomes to tell which microbes are truly alien and which ones are just us. At the same time, calling microorganisms a civilization would be a stretch. And let's be honest, a few alien bacteria aren't going to excite the public the way humanoids with technology would. The real question is, where could such a civilization actually live? Today, the most popular idea is exoplanets, worlds orbiting at the right distance from stars similar to the Sun. One star in particular has hooked astronomers, the red dwarf Gliese 251, about 18 light-years from us. That's incredibly close by galactic standards. At least 2 planets orbit it. One is practically glued to the star, most likely pure hell. But the second, Gliese 251c, sits at a distance where temperatures might be similar to Earth's. Not too hot, not too cold. Water there could potentially exist in liquid form. The problem is that red dwarfs are tiny stars with a big temper. They're small, volatile, and their surfaces live in a state of perpetual meltdown. Flares, eruptions, torrents of plasma. Their brightness and spectrum change so chaotically that trying to detect a planet around them is like trying to pick out a whisper in a rock club. And even if we manage to find a promising planet, our technology in the near future will only let us guess whether there's any life there at all. So while the exoplanet idea makes sense in theory, it's almost useless in practice. Far more intriguing is the idea that maybe we should be looking for life near black holes. Because the most advanced civilizations might deliberately migrate toward the center of the Milky Way, toward the supermassive black hole. At first, it sounds like interstellar on steroids, but there's a rock-solid physical reason behind it: time dilation and strong gravitational fields. General relativity says this clearly. The closer you are to a massive object, the slower your own time passes relative to everywhere else. Near a supermassive black hole, time for someone on orbit runs slower than for those far away. Now imagine a civilization truly determined to study the entire galaxy. The Milky Way is about 100,000 light-years across. Even if you build a probe that flies nearly at the speed of light, it would still take tens of thousands of years to cross the galaxy, gather data, and return. For a species with a lifespan like ours, like a couple hundred years at best, that's pointless. You'd send a probe, and by the time it reports back, your civilization is gone or completely unrecognizable. But if you live where time is drastically slowed, near a black hole, then for you, maybe 100 or 1,000 years pass, while millions of years fly by in the rest of the galaxy. In that span, your probes could sweep across enormous distances, return home, deliver their data, all within your own lifetime. From this point of view, the galactic center with its supermassive black hole becomes the perfect scientific bunker for a hyper-advanced civilization. All the danger remains outside, and the information streaming toward you is sped up simply because of how time flows. The only catch is that this leaves us waiting for someone to find us, and if no one has found us yet, maybe we really are alone. This is where our journey runs into a wall of theories and paradoxes. Back in the mid-20th century, physicist Enrico Fermi came up with a question that still hits us right between the eyes. If intelligent civilizations are common in the universe, and even a small fraction of them are just 1,000,000 years older than we are, then where are they? In the last 50 to 100 years, our own civilization has leapt forward at a ridiculous pace. We went from telegraphs and primitive aircraft to satellites, nuclear reactors, interplanetary probes, the internet, and space telescopes. The progress may feel less dramatic now, but the fact remains. In a single century, we reshaped our entire planet, now stretched that not across one century, but across 1,000,000 years. Even if a civilization has periods of stagnation or regression, a species that started only 1,000,000 years earlier than we did should have at least launched something into space. A probe, a beacon, a megastructure, anything. In that scenario, the galaxy shouldn't look as empty as it does today, but we don't see a single clear sign of technology on the scale of a star system, let alone a galaxy. No Kardashev-type civilizations blazing with obvious engineering. Nothing. Fermi drew a brutal conclusion from this. If we don't see anyone even though we should, then most likely no one is there. Either advanced civilizations are incredibly rare or incredibly short-lived, or the path to a galaxy-spanning technosphere simply doesn't exist. Today, there are 1,000 counter-arguments to that logic, and one of the most interesting is the loneliness zone. What if we're not the only ones, but just the first? Or, much more grim, what if we're the last? We're forced to think about the universe in terms of time. What is 1,000,000 years to a human? An unimaginable gulf. But to the universe, it's a couple of months on the cosmic calendar. So, it's possible we're standing at the dawn of the universe's intelligent life, and it's on our shoulders to either build the first interstellar civilization or eventually find and help another one grow. But from the same perspective, we could just as easily be the final survivors in a universe that is quietly winding down. Either way, the search for extraterrestrial civilizations is an incredibly delicate endeavor. Even catching a single alien radio signal requires pointing a telescope at the right patch of sky at the right moment. No wonder the question of alien life will keep us restless for a long time. And if we do find something in the near future, it will almost certainly be microorganisms, and those might even turn out to be our own. But is that really such a disappointment?